lesson on radical equations, how to solve them for Algebra 1. Please make note of the steps here, and then I'll go through them. The first thing we're going to do is isolate the radical. The radical expression has to be by itself on that side of the equation. If there are two radical expressions in your equation, then one has to be by itself on one side and the other has to be by itself on the other side. If that's not the case, then you can't solve it in Algebra 1. Not that you can't ever, but you can't solve it in Algebra 1. Okay, once you do that, we're going to square both sides, and then we're going to check all of the answers and disregard the extraneous solutions. For example, when you get the square root of a negative number, the solution is extraneous. Or when a square root equals a negative number, it's extraneous. At least while we're in Algebra 1. Later, stay tuned. Okay, let's try a couple of these. Let's see, first one up. Who wants to help? Krish, you can help me. Look at this and tell me how to do it. I can hear you coming down through the wire. Here we go. Okay, what was our first step? Our first step was isolate the radical. Okay, well, I done spotted the radical. Now I'm going to isolate it. Right, Krish? Here we go. So minus 7 minus 7. That'll be the square root of x minus 5 equals 5. Okay, cool. So now the next step was square both sides. I squared both sides. And I remember squared, unsquared, squared, unsquared, squared, unsquared. Okay, it was x minus 5, and we unsquared it, and then we squared it. Yes, I know there's no such thing as unsquared, but hey, it sounds cool. All right. So that gets us back to x minus 5. I had x minus 5. I square rooted it, then I squared it, so I get back to x minus 5. Kind of a toggle there. And 5 squared is 25. I isolate my variable. And yes, indeed, x is equal to 30. Now, with these equations, with square root equations, with radicals, sometimes you can work the whole thing and get an answer and it looks good, but it's no good. Don't let it fool you. Don't be suckered. You have to go back to the original equation and make sure that it works, because it doesn't always work. Let's see if that works. The square root of 30 minus 5, let's put in the 30 for the x, is the square root of 25, which is 5 plus 7 equals 12. Yes, it works. It's good. The answer is x equals 30. Okay, let's try this one. Who's going to help me with this one? This one. Olivia, you can help me with this one, right? Okay. Is it already isolated? Yes, it's already isolated. Yes, indeed. So all I have to do is square both sides. Well, there's 2 of them, and each one of them is isolated. That means there's nothing else. If there was something else, you can't solve it in Algebra 1. So you just go like, oh, miss, I think you made a mistake. And I probably did. So here I'll square both sides. Again, squared, unsquared. It was x plus 4. Then it's unsquared, then it's squared, so it's back to x plus 4. A little toggle switch there. And I'm running out of ink. Okay, well, here, let's get some ink. All right, ink time. Okay, got me a new pen. So now we're just going to solve it from here. We just use our regular algebraic manipulation that we're accustomed to. And it doesn't matter which order you do this in. Actually, this way kind of makes it one extra step. So it would have been better to put the x over first instead of the 4. Here we go. Multiply both sides by negative 1, and I get x equals 5. Now again, you got to check it, because it might not work just because you did everything right. These radical equations can really be silly. So Olivia is telling me I have to go back and check it. So I'm going to go back and check it. So that's the square root of 9 equals the square root of 10 minus 1. I'm thinking that's the same thing. That's 3 equals 3, so it's good, and that's a correct answer. Okay. Now let's try another one that's kind of on the iffy side here. Okay. Let's do this one. Okay, it's got 2 Oh no, this one isn't it. This is just another example. Sorry about that. This one will work out. Okay, so I have two radical expressions, and I got two sides of the equation, but they're both on the same side. So I get one to the other side. This one's easier because I don't like negatives. I can look at it and I can see that once I do that way, the negative will go away, which I'm pleased and happy to happen. Okay, so again, now, Betty, can you confirm? Yeah, look, they're two radical expressions, and they're each on their own side, and they're isolated, and there's nothing else. So we're good. So Vanny says I'm good to go. So now I can square both sides. There we go. Again, squared, unsquared, squared. So I get back to the radicand, and then I just solve it out. When I come down to this, let's see, I'll subtract an x, so that'll be 3x minus 3 equals 0. Add a 3, 3x equals 3, x equals 1. Well, let's see if it works. Original equation, not the modified equation, the original equation. So that'll be 4 times 1 minus 3 minus the square root of 1 equals 0. Well, let's see, that's 4 minus 3 is 1, so that's the square root of 1 minus the square root of 1 equals 0, and I'm thinking that's right. So this answer is a good one. We're good with it. Okay, now let's try this next up. This one's going to get to be a little problematic, and you're about to see why. First off, is it isolated? Yes, my radical expression is isolated. It's the only thing on the left side of the equation. So I'll just square everything on the left and square everything on the right. That'll give me 6 minus x equals x squared. Uh-oh. Alert, alert. This is a quadratic equation. Remember, a quadratic equation, you have to make it equal to 0, and then probably I can factor. Solve it by one of our multiple rings. Okay, so I've got to make it equal to 0. I'm going to subtract the 6, and I'm going to add the x to both sides. That'll give me x squared plus x minus 6. And we know that that means that the 0 is going to be y, but we don't have to worry about that because it's, remember, the y is always the 0 because what we want to know is the value of the equation when it crosses the x-axis. And conveniently at the x-axis, the y value is 0. Okay. Oh, I wonder what'll work there. Well, let's see. I can factor AC, A times C, is negative 6, and B at the bottom, B bottom is 1. There's B, A, B, C. A times C is negative 6, B is 1. Remember, A x squared plus BX plus C. Okay, so now I have to say what multiplies to give negative 6 and adds to give positive 1. I play through it, go through them all, and it's 3 and negative 2. So I'm going to replace my x with 3x minus 2x. Okay. And I'll just copy the other stuff around. Now, once I've done that, I can group it, take the common factor out of the group, other group. Yes, I won. It's got x plus 3 in both places. Remember, with this method, it's got to be the same thing in parentheses. Then you make a group out of what's left over, the leftover group. And it is now factored because I can factor. Okay, from this point, we know that either x minus 2 equals 0 or x plus 3 equals 0. X minus 2 equals 0, x plus 3 equals 0. This would be x equals 2, and this would be x equals negative 3. Okay, we have to check them. Do they work? Well, here, let's look back to the original equation. And the original equation was the square root of 6 minus x equals x. So let's put that in here and see what we get. Okay, so if x is 2, that would be 6 minus 2, which is 4, and the square root of 4, which is 2, equals x, or 2. So 2 equals 2. Yeah, that one works. See what we would have here? I guess I should write it out. The square root of 6 minus 2 equals 2. Okay? That'll be the square root of 4 equals 2, and 2 equals 2. And of course, it could also be a negative 2, but since we were given the positive one, it can't actually be a negative one. It has to be the positive one. Because remember, if you write in the radical, you have to get it to be plus or minus. But if the radical is given to you, it is presumed to be the principal root or the positive. So there's only one answer to this one, and it's the plus 2. And that's because the radical was already given to you, and there was no negative out in the front, and positive is the default. Okay, let's do this one right here to make sure about it. Okay. So this will be, for the second solution, x equals negative 3. That would be the square root of negative 3 minus, oh, excuse me, I'm sorry. That would be the square root of 6 minus a negative 3. And let me remind you, always write out all the steps the first time you copy this down. Don't do it in your head. The most common mistake here would be to put 6 minus 3. It's not. It's 6 plus 3. Oh, right here you know something's wrong. Look what I just did. I just wrote some square root, that's positive because that's the default, is equal to a negative. Is there any time that a positive is equal to a negative? I don't think so. The closest thing would be 0, but it's special. It's not positive or negative. Okay, so here we have 6 plus 4, which is 10. The square root of 10 does not equal negative 3 anyway. So once you get down to here, you're going to know you did it wrong. Okay. So next thing up, we're going to try a few examples here. Another one. Okay. Let's just try the square root of 5x plus 5 equals 0. I'll isolate my radical expression by subtracting 5. That way I'll have the square root of 5x equals negative 5. Again, this one was given to you. This is the principal, or otherwise known as positive, root. It is not the negative. The reason for that is this was given to you and it doesn't have a negative out in front, and the default is a positive. So since it was given to you in that fashion, it's positive. Now, if it were given to you as plus or minus, or given to you as negative, then that would be the case. That would be what you do. And the main time, however, you got to deal with this plus or minus is when you're the one who initially draws the square root sign. If you're the one that takes the square root and it wasn't already given to you, then you have to remember it can be both. This square root was already given to you and it's positive. Now, some of y'all had some trouble with that on the quiz from last week, and I'm going through, and I'll go through and double check to make sure how you put that, to make sure if it's right or not. Okay. What do we have here? We have a positive number equals a negative number. No way. However, if you're just going through and not thinking as clearly as you might sometimes, if you keep going, you will get an answer. So, for example, I'd have if I keep going, I'll square both sides. Have to square the negative. I'll get 5x equals 25. X equals 5. Notice I get a perfectly good answer. this answer looks really good. 5, that's a nice number. I like 5. It's how many fingers I got. No, it's no good. Don't get suckered. You have to substitute it back into the original equation. So we'll have the square root of 5 times 5 plus 5 equals 0, or 5 plus 5 equals 0, or 10 equals 0. It does not equal 0. What's wrong with this? This was the way it would be right if this were not the principal square root, the principal root, okay? If this were a negative, it would be true, but look at the original problem. It is not a negative, so this is not a correct answer. It's just no way, no way, no way. Okay, here's some examples. This is number 6 that's right here that I just worked for you. If you would, pause it and work a bunch of these till you feel that you're comfortable with it, and I'll put the answers up. Okay, here's the answers. See how you're doing. And here endeth